In this video, we'll begin our discussion of the graphs of sine and cosine. These will go pretty quick at the beginning, and then we'll learn how to move these around. The hardest part will be, I think, applying these to some examples, like real applications. Okay, so I went ahead and did the long part, so you guys didn't have to watch me type something in the calculator. I really wanted, though, even though we could find our unit circle values and pull that down, and I expect you guys, I hope you guys did well on your test on that side. I went and plugged everything into calculator to give me decimals. So what we're going to do now is, what we're used to so far is we would graph cosine and sine based just on the circle, right? The unit circle, like this picture down here, right? Or the unit circle provided there at the bottom. But what we would like to do is actually take each of those points and give it an x and a y and make it go left or right like we're used to, like a parabola, anything like that. So what we'll do is we'll let x equal 0, and we're going to graph it, my x-axis being here, y-axis being here, instead of the circle, and we're going to graph each one. So 0 is at 0, okay, at pi over 6, so pi over 6 is, okay, if we need to think about these, do you see how they split pi over 2? It's right there, so we could think about this as pi over 6 and pi over 3. All right, so, okay, pi over 6, it goes up to 0.5. And those are split evenly, okay? And then pi over 4, that's right between pi over 6 and pi over 3, it's at 0.7. The dash up there is 0.75, so I'm going to put it close. And then for pi over 3, it's going to be 0.86, so it's somewhere up here. And then at pi over 2, we have a 1. So we get this kind of like very smooth, it's supposed to be smooth, curve coming up like that, all the way to the top of 1. And then at 1, and we started doing less values over here because we know it's going to have the same kind of growth. I know at pi over 3 it's going to be that same point. There's my 0.86. And then I can use these exact points here. This is going to be in between somewhere. And then pi over 3 is at 0.5. And then back at pi it goes back down to 0. So we have a really smooth, if we can do it here, very smooth graph like that. And then we didn't graph a bunch of these, but we see that it goes back down to -1 right there at 3 pi over 2, and then back up to 0. So it looks something like that. And it's very smooth, not pointed at the top. And it goes on forever. I could keep going by doing more angles that way. I could keep going by doing negative angles or negative rotations, and we get this sine wave that you guys are used to seeing in movies or anywhere you've seen sine before. One thing I want to notice is the domain of this function, right? Let's write these in. The domain, I can plug whatever I want into it. All angles. We already knew this, right? Negative infinity to infinity. And then the range, we talked about it with the unit circle, but we can even see it even more here, that it bounces back and forth between -1 and 1. So there's our graph of sine. Cosine's not going to be much different. So I provided a couple of visuals here. The visual right under domain and range shows the heights of our sine, right? Remember, sines are y, so we get them directly across, and that's what we're doing here. It's just this is a function based on x and y rather than a function of x's and y's based on an angle. I hope you can see the difference. In this case, x is an angle rather than a side of a triangle. All right, let's take a look at cosine. We'll do more work with these. So cosine, I filled in the table again if you'd like to fill that in. And we're going to take a look and see what happens here. This time, my graph is going to start at 1. And then if you look, it's the same exact values. So at pi over 6, it's going to be 0.866. At pi over 4, it's 0.7, little underneath. And then at pi over 3, it's going to be 0.5. And then pi over 2, it's back down to 0. Right? And then it does that same thing going down. So we have it down to here. Halfway through will be about 0.7, and then 0.86, and then at pi it's at 1, and it just does this continually. So I'm going to go ahead and draw it. It's like that here, and then it's going to go back up at 3 pi over 2, and then all the way back to 1 there. This is how I really think about this once we start graphing. If you notice most of these, let me highlight some points. These are the only ones I'm going to think about when we start graphing these. I know it's smooth in between, so all I have to do is connect those, but we have 5 points that are very easy to see there. Take a look at the sine function too. Let me go back up real quick. We have 5 main points here too that define our sine wave. We start on the line, we go up, we go back down to the line, below the line, and above. What we're going to call this, and we'll call it later, you'll see, we'll call it midline, because you can see where that's where the graph is going up and down around that line. Same thing here for cosine, but notice it's just shifted over. Instead of starting at 0, it starts at 1, which we should have down at this point based on our unit circle. All right, these are periodic functions, which means they will repeat and repeat and repeat. So we are interested in their periods. How often do they repeat? These functions are periodic, and they both have periods of of 2 pi. So sine, I was about to write sine, that's why I said that. So sine of x, its period is 2 pi. It takes from 0 to 2 pi to repeat. So if I were to put a marker every 2 pi, we'd see that same shape. Same thing for cosine, except for it doesn't start on the midline, it starts above it and ends above it. So there's that period. Cosine has that exact same period. Tangent and the other, tangent and cotangent will change, but sine and cosine will have the same along with the reciprocal functions. We also can lean into the idea of even odd functions here. Remember that an even function, let's start with odd. Odd is, this one is odd. It takes in different inputs, opposite inputs, and produces opposite outputs. Or, it's symmetric about the origin. If I were to spin that 180 degrees, I would land in the same shape. Even functions take in opposite outputs and put in the same. So when I plug in pi over 2 and pi over 2, I get the same input. If I were to pick a value in between, those are the same output. Opposite inputs give me the same outputs. We can tell this just by the graph. Sine starts on the midline, cosine starts above the midline. We're going to say that quite a bit.